Alright, should be streaming live and such, I think. I don't see it yet. Close enough. Alright, I think I'll pop out the chat. And I have to do that. Should have done that first. Well, whatever. Doing the best I can. Anyway, let's see if the microphone keeps working. I have to keep my eye on that, I guess. So yeah, I guess that's it. Good enough. So, yeah, I was going to talk about springs, springs. But I've decided to first talk about levers. And I'm just thinking about what kind of experiment to do, what's easy enough to build and would be decisive in the outcome. And I do like the idea of the lever launcher, so I might talk about that. But I'm first going to talk about levers in general, balances, and the different ways that you can understand their function and make logical statements about what must be true. And so even without experiments, but obviously experiments would solve this. And the fact that we can't link to any physics experiments where they actually test whether springs store momentum or kinetic energy. So there's all kinds of discussion. AI says they don't store momentum. Some other physicist that, whatever his name is, I can science that, says, yeah, you need 4 spring compressions to move something twice as fast. You have to compress a spring 4 times as much to go twice as fast, which doesn't make any sense. So I'll make some arguments about that. But I guess I wanted to start with this lever thing because it just sticks in my craw, so to speak, that this is sort of a decisive argument. It really shouldn't have to go any further than this, in terms of making an argument about how the universe functions. So the test I did, is to have a lever. Didn't put that in the center, but just imagine it's in the center. We'll put a little extra on here. Okay, imagine there's little extra end points. With one mass at 4 distances, 1, 2, 3, 4, and a 4 mass at 1 distance. Alright, and it oscillates perfectly. Okay, so you give it a motion, and it just keeps going and going and going. Okay, for whatever, 5 minutes. Depending on how light and long your lever is, it can be quite efficient and keep the energy is maintained, and even though there's air resistance and it's losing some energy, it does pretty well. I'd like to see that in a vacuum, actually, just to see how long, because it's such a little tiny bit of loss to the actual suspending object. And so all the losses really have to be air resistance. And if you got rid of air resistance, how long would it just keep oscillating? Be interesting to know. Anyway, another experiment we're never going to see. All right, and I'm arguing, that you can really understand what's happening in this experiment by, zooming into the fulcrum. And the idea is you're recognizing that you're supporting it from the top, And that's the key, that when you tip it, that is when it goes in one direction or another direction, you can sort of understand that what's really happening is because of that straight line, you're basically putting, more of the lever on one side than on the other side. So if this was the suspending point, you can understand that the straight line would be here, which means by the gravitational, the mass straight line, you can sort of understand that you've now put mass on this side. You've added mass to this side of the lever when it tilts up. And that's what's slowing it down. So it's moving, right? But it's gaining mass with every degree it tilts. It's getting heavier on that side. The gravitational mass of the lever, this side of the lever is actually getting heavier, this side's getting lighter. So obviously now it's going to tip back the other way. And it doesn't matter. I can have these masses on, or I can take the masses off, and the lever will do this. It will just oscillate. So we know that the masses are irrelevant in the sense that they must be doing exactly the same thing. They're putting the same pressure. So, because we're not changing gravitational height significantly enough to change anything gravitationally. So it's just about this little sliver of mass is just switching from one side, and then when the lever tilts the other way, that extra mass goes on the other side. And so you're just taking, a portion of the mass is just switching from one side to the other side. And that's why it's oscillating. And that's why it oscillates slowly, is because it's a small amount of mass that's switching sides. So it's not much energy, in the oscillation. You can't make it oscillate, fast. You can only make it oscillate, period. You go too fast and it just spins around. So it's always kind of stuck with only being able to store the energy of how much of a degree of oscillation you have, but you can't do any more than that. And it's always going to move at essentially the same speed dependent on the mass of the lever, how much mass this actually adds up to. But that's all that's making the difference. And so that when it's oscillating this way and this way, that, what it's doing, these two things have to be putting the same pressure on the lever. They can't be putting a different amount of pressure. They can't be weighing a different amount or any of that. They have to be exactly equal because it's exactly the same mass on both sides. It's switching sides. So I'm moving the mass a little bit this way. I'm moving the mass a little. So I could do the same experiment. I could just say, all right, I got a little piece of extra mass here in the middle, and I'm just going to move it over to this side, and then I'm going to move it over to that side. The oscillation couldn't be the same if it took more energy to move one side than the other. So the two sides have to have the same energy. But the kinetic energy theory says this one's got twice the energy over here. The one mass, well, let's see, one mass moving 4, so that's 1 times 16. Yes, that's 16. And this is a 4 mass moving 1, so that's 4. So yeah, it's 4 times. It's 4 times the energy. So by their theory, there's 4x the energy somehow in this object, and there's 1/4 of the energy in this object. Now, do I really need to, for rational, reasonable people, isn't that saying, okay, come on, there's a problem here? Somebody should point out how there could be 4 times the energy on one side of this stick than the other. Because if I let the stick hit me when it's going up, or when it's going down over here, it's going to feel exactly the same. It's moving exactly the same speed. I can't make it move a different speed. It has to always move. This side has to move the same speed as that side. And all I'm changing is the position of the masses. So how is it possible that you don't understand that that's a decisive proof that their kinetic energy theory can't mean anything? Because this side of the stick can't possibly hit anybody harder. It can't do anything to anybody any more than this side. It can't make any difference even if I let the stick hit somebody here, at half the distance. All right. Yeah, it's going to hit slower, but with more torque. And the same is true over here. If I let the end of the stick hit here, it's going to be just like the end of the stick over here. It's not going to make any difference. It's a mass moving a velocity, and that's all you're going to get hit with, is this total mass of the stick moving a velocity. I just don't know why I have to do this over and over again. Now, yeah, it'd be good to have proof. I'm just saying, this experiment I've done, I'm sure you can find this somewhere on the internet. So this experiment shouldn't be in dispute. The fact that this oscillates perfectly evenly, completely symmetrically. No indication of 4 times the energy on one side than is on the other side. Every indication that, yes, it's obeying momentum, the law of the lever, it's working perfectly, and that's all there is in here. There is no room for the kinetic energy theory. It's clearly just a momentum event. I mean, it's got to be understandable that you're moving something against gravity, okay, but you're doing it at a speed, okay, that's decided by the lever. So, the momentum is the same because you're changing the speed. This is moving 4 times the velocity. It's not these aren't in free fall. Their velocity is completely controlled, and this is moving 1 velocity. And it's about the momentum, not gravity. Now the proof is that, let me erase this a little bit, is that, you know, if I want this lever to show you how it doesn't have anything to do with the masses, that they're not the issue. Gravity's not really, it's playing a part, but it's playing a part in a subtle way. I can just do the experiment differently by having the lever suspended by a fulcrum right in the middle. So if I put the fulcrum in the middle to do the same experiment, it won't work. I mean, that's a 1 mass and 4 mass in here, you know. Because this, okay, isn't going to, when I tilt this, I'm not going to change how much mass is on this side and this side, right? So as this moves over, this one moves over. So I'm always going to have the same mass. There's never more mass on one side of the fulcrum than the other side. So it just doesn't care. So I can put it in any position and it'll stay there. So it just doesn't matter. I got the 4 mass over here, got the 1 mass, 4 mass down here and 1 mass up there. And as long as the masses are the same, it'll just stay in that position because there's not enough gravitational difference. It's 9.8 here and it's 9.8 here. It's no, gravity doesn't have enough of a difference in that tiny range to actually make it fall down. So it'll stay in any position I put it in. So it's clearly showing that it's not about the weight of the objects. It's about their motion and how much energy you need to move them. And that's what's controlling the experiment, the momentum. All right, that's part 1. But I mean, it's so clear. I mean, obviously, like I said, just, and if I put the fulcrum below, you know, it's even more interesting, right? Because that's the traditional drawing, right? But this is a terrible balance because it has exactly the opposite effect of this one. Where this one puts the mass on the side rising, this one puts the extra mass on the side that's tilting. So when it starts to tilt, it goes all the way down. So once it starts to move, it goes all the way. You know, it's not going to oscillate because as it moves down, it adds more mass on that side. So that side's definitely going to go all the way down. So this lever is more likely just to swing all the way. So balancing is very delicate. You can do little tiny changes, but any big change, it just swings down. So these are facts about how levers work. No physicist wants to talk about how these levers work, and they certainly don't want to do any experiments with them. And you know, you should be bothered that they don't have any experimental evidence, that we can't go to any Professor Lewin video, we can't go to any physics lab video anywhere where they actually do these experiments. None of them. They don't do any of these experiments. I mean, again, the simple experiment of just turning a scale sideways. How many times have I done this? You really don't think this is something physics should have done? I mean, they've had spring scales for probably 400 years, right? Probably, at least. I mean, just turn it sideways and then swing a pendulum into it and see what kind of impulse you get, and see if you can duplicate the fact that if you take 100 pounds and push it in and it weighs 100 pounds, and you'll see exactly what momentum you need to make 100 pounds. And the argument, the drop is actually 1 centimeter. So I'll go over that again. I mean, it's just, so I can't take any of you seriously as people participating in any kind of honest way. So I can't see how an honest person can't just admit, yeah, these experiments should be done. I mean, these experiments should have been done back in Newton's day. I mean, they could have been done back in Newton's day. And you're just saying, why weren't they done? I mean, it really isn't that complicated. Nobody could analyze levers and explain the 3 ways, you know, the fulcrum at the bottom, the fulcrum in the middle, the fulcrum at the top, and point out how their distinction. I have to do it? I mean, it just shows how little interest there was and how much it's just a religion. It's just about confirming the faith. It's about finding the Shroud of Turin or finding some scroll somewhere that'll prove, some kind of bullshit. It's not about testing their theory. They don't want to test their theory. They just want to confirm their theory. Oh, look at all these comments by one guy. Disappointing. Let's see. You don't seem to understand that the lever you have drawn is basically a pendulum. No, it's not. So go to hell, fuckhead. The center of mass is swinging back and forth. What center of mass is swinging back and forth? I explained how it's the center of mass is moving from one side to the other. It's gaining mass on one side, losing mass on the other side. Jackass. This is something that bright fifth grader... So again, there's no point in this. You really think I'm going to read your comments if this is the best you can do? Where's the experiment, fuckhead? Why isn't there a fifth grade experiment? Why can't I play a single fucking video on YouTube demonstrating your theory that is 4 times the energy on one side of that lever? You fucking piece of shit. Alright, anyway. Although, to be fair, I never went to public school. You're just such a piece of shit. He thinks he's gifted. Oh, hilarious. All you do, you're whatever. You got an extra big asshole. That's all you've got. My frame of reference, fuck you. I actually teach at university level. Oh, we already know what a university level professors are like. All right? Cowardly, lying sacks of smelly, dirty shit. So that's not a badge of honor, because we've seen how they behave. You're just fucking mullahs. You're just part of a religious cult. Okay, and to me it's all nothing's, elementary with no evidence. You can't show me it taking 25 times the fuel to move anything 5 times as fast. Nothing. Not a single physical example on this planet. You fucking piece of shit. Oh, these people are such liars. Alright, different parts of the pendulum have different amounts of kinetic. The liar. They don't. They can't have different amounts. It can't oscillate. If I put the same mass on this side and it moves, and then it moves exactly the same speed when I put the mass on the other side, then there can't be any difference. That's the whole point. The only thing the pendulum sees, or the lever sees, is the fucking goddamn momentum. It can't see anything else. It doesn't interpret anything else to exist. It just doesn't exist. Alright, anyway, you're such a liar. Alright, different parts of the pendulum, different amounts of kinetics. It's just a lie. But the difference between the potential... we're not talking about baby talk. There's no such thing as potential and kinetic energy, okay? You store energy. You're in a stream, right? I put a boat on the side of a river. The boat doesn't have any potential energy. I have to put it in the river. Okay, gravity is a river, all right? It's kinetic. It's full of energy. And you can put things in it, and the amount of time they're in it will decide how fast they move. The amount of time they're in it will decide how fast they move, just like in a river. Oh, you people are so fucking stupid. Oh, wind resist. What a stupid thing to even bring up, moron. Oh, it has absolutely nothing to do with a pendulum oscillating at these incredibly slow speeds. Also, the momentum of the system is also conserved because the ground is infinitesimally shifting. Yeah, it says you. Okay. We can't perceive it. Yeah, you can't find it. You can't show it. You can put a scale underneath the whole thing, and the scale won't read any differences at all. It won't indicate that there's any changes anywhere. Nothing changes whatsoever. The pendulum can fly all over the place, and the scale will read the same mass. Fuck you. You're so full of shit. So it seems as if the momentum is changing and reaches maximum. So there's no point. Obviously, the total momentum isn't changing. At every point, both of them are going their maximum speed at the middle point. So lie some more, jackass. All right, by the way, I mean, you're just such an asshole. Where you talked about driving home drunk at your bar job. I never said that ever, so I'm blocking you right there. I never ever said I ever drove home drunk. So go fuck yourself. You're an idiot. I mean, it's just disgusting that people he's lying about the physics and he has to lie about my life. Just go fuck yourself. Jesus, what pieces of dirt occupy this planet? I mean, just nowhere acknowledging the subject at all. Can't link to anything, can't say anything reasonable, just nothing. No reasonable contribution. Alright, let's see. I can't get the opposition to admit there needs to be experiments. The variety to prove what's being claimed. Yeah, well, I mean, you don't even need much. Right? Are we asking for much? A lever, for fuck's sake? They won't confirm how a lever functions? They won't do that experiment? Whether it conserves kinetic energy or momentum, whether, I mean, again, they're claiming that somehow I can put, I mean, this is actually their claim, there's nothing, I can't describe it in some other way than just to say it's just this silly. I mean, they're saying you could put a 2 mass in, okay, with 1 V, all right? And that somehow, if I put the, 2 units of distance, I put the 1 mass over here, I'm not going to conserve the momentum. And I'm just going to get 1.4, the velocity here. 1.4. And if I put a 3 mass over here, I'm going to get 1.7. I mean, that's their argument. I need to put a 4 mass. I need to have a 4 mass hit here, okay, to get a 1 mass to go 2V here. That's their theory. On its face, it's ludicrous, right? And there's no way they could do that experiment. There's no way it's going to be shown to be true. It's so fucking stupid. And yet I have to make these videos. I mean, it really is discouraging. Yeah, that's the word. It's discouraging to live on a planet of belligerently stupid people. And they're all belligerently stupid, ignorant, wrong, deluded, silly, fucktarded, evil, moronic. Just disgusting. All right. So, yeah, so I guess I'll do a little bit on the springs now. I guess I'm done with levers. I don't want to be done with levers because this is just so obvious. All right, so I am thinking, how to do the lever experiment, in the most precise way. And I do like the lever launcher. So the idea of a spring producing the same consistent force. And again, Brozo already did it, came up with pretty good results. But, yeah, it'd be better to get perfect results. So, it would be something similar, like a piece of glass. I have some plastic pool balls, little ones, from like a miniature pool table. That probably won't be too hard to cut. So I might even do that thing where you cut them to make them the right mass, half the mass. But I could glue 2 together. Remember, they certainly won't roll, if I shoot them forward. So I could do 2 of them glued together and then 4 of them glued together. Then we wouldn't have to worry about any angular rotation. So we'd take that out. And so all there would be is the friction argument. And the distance we're going to have them travel is pretty short, so technically that shouldn't be an issue, because you're not going to see how far they go, you're just going to see how fast they go, how fast they were going when launched. That's that's the only information you want. So the sooner you stop them and get how far they moved in what amount of time, calculate their velocity, you've got all you need to know. Alright, so we're back to sort of the scale argument, and so I'm thinking I want to make another one of the 5-minute style videos, but it's just so hard to say everything just right so people get what's just kind of obvious. Alright, so if I had a scale, okay, and I I don't know if I need a bunch of lines in it or not. Anyway, so that's a scale. And I put a mass on it. Alright, and it weighs the mass. So what I get is a reading on the scale. So let me just do a standard size bar and just say the scale reads a line. Okay, now we know by Hooke's law, the simple rule is going to be if I put a 2 mass on here, alright, it's going to read 2 of those same notches. Right? And so my simple argument is this really has stored in it, okay, the gravitational potential for these 2 objects. And if I tilt the scale sideways with, holding that position, that I'm going to get back what gravity put in. So I'm going to get back the weight, okay, as momentum. The scales, there's now nothing holding. There's no constant force pushing on them. So if I have one of the balls on the scale, the point would be is how fast is it going to go. So if it's 2 notches, the argument is it's going to go twice the velocity. And if it's just one mass worth versus 2 masses worth. So with 1 mass worth, you're saying how fast is this going to leave? Well, my argument is no choice, because technically the speed going in was 1 mile an hour. That was the momentum you need. That's the momentum you need to push the scale. 1 mile an hour will make this thing weigh exactly what it weighed here. So if I take this object on a pendulum and I lift it 1 centimeter and I let it swing in, it'll be going 0.44 meters per second. And that translates into 1 mile an hour. So that's the velocity that'll make this 1 ounce, let's say it's 1 ounce, weigh the same as this 1 ounce. It'll make the same notch. It'll hit the same notch on the scale. It'll be 1. And obviously, if I take the 2, and lock it at the 2 position, the 2 mass, well, that means there's 2 of those, twice that amount of weight, twice the amount of momentum that's in the scale. And the fact is, I'm going to get 0.88 out. It's going to go twice as fast. It's going to leave with twice the velocity. Now, that's the only way I can conserve momentum. And there's just no room in there for any notion that the thing going twice as fast has 4 times the energy. Because where did I get the 4 times the energy? There's not 4 times the weight on here. How can twice the spring compression be 4 times the energy? I can't get 4 times the energy out. I get twice the velocity out. That's all I get. I just don't know how people keep keep believing that there's some other truth. But again, is this a simple experiment or what? I mean, to just sit there and say, okay, I can weigh something, I can take its weight, and I can see the number on the scale. Right? I mean, I could do it, but I'm just saying I'm not going to be able to do it well enough. I mean, I got a shitty little scale here. I put a battery on here, or a weight. All right, and I see the number it weighs. And I simply turn the scale this way, and then I have to, the problem is now I have this little extra mass that's just going to get in the way. So I have to reorient the scale, I guess. So it's going to be a little off because it has to move this table now. Because the table is moved by gravity here, and it's not going to be moved by gravity here. So I have to do something to compensate for that little bit of pressure that I'm not going to have anymore on this thing. This stupid plate. Because now I have to use the energy I'm putting in. I can't use gravity to move the plate. I have to hit the plate. Well, anyway, but yeah, I can compensate for that. No big deal. So I put the spring on the mark, and now it's going to do exactly what it would do, here, right? And it's going to push. So how can I say that this isn't going to be capable of moving it at exactly the same weight here? And that whatever motion I get out, you could argue if it was a pendulum, right, and I put it here and I smashed it, it's going to swing out and then do the same thing. It's going to weigh its weight again. If it's, with losses. But I mean, it's going to be pretty close. So where's the room for any theory of kinetic energy? There's no way I can say that twice the compression is 4 times the energy. I'm just going to get twice the velocity. It's twice the velocity in makes that notch. How could it be 4 times the energy? I mean, I guess I can keep saying that. How can it be 4 times the energy? So again, this just keeps going back to the gravity argument and the fact that they can't acknowledge that gravity is a time-dependent force. So even though explicitly it's time-dependent, that is, it's 9.8 meters per second of extra velocity per 1 second. It's in 1 second chunks. You don't get 9.8 per seconds or per any second. You get it in 1 second units. You have to be in the gravity falling 1 second to get 9.8. You don't get 9.8 if you fall a half second. You only get 9.8 if you fall the full second. You have to fall the full second to get the 9.8 velocity. And you only get the 4.9 in actual distance because of the fact that you're accelerating, and it takes time to acquire your velocity. Oh. Wow, it's Saturday night. You'd think there would be more viewers. But 2. Ooh. Alright, so I'll do the gravity argument real quick one more time, and then get out of here. So did I say all I wanted to say about springs? Yeah, so there's just so many ways. We can play with springs, you can sit there and play games with it, bouncing around, see how much energy it takes to move them. But, it all should be done, I was just doing this simple experiment, where you just compress it and shoot it. And you can see you can get almost any kind of value out of it. And it really depends on how it, how it compresses and releases. And so you just can't have any friction and all that kind of crap. So, there's all these little variables that you have to check. But these aren't complicated experiments, but they do require a little bit of precision and care. You have to be a little bit careful in how you do them. But they should be doable. But it's just, why do I have to do them? Just, 350 years of scientists investigating all kinds of wacky crap, and not one of them thought to do some spring experiments? Not one? I mean, it's still just, like I said, I just sit here in amazement. I'm just saying, not one scientist thought of the idea that, well, let's see how fast something has to go to weigh its weight. How fast does it have to go to weigh its weight? Nobody thought to do that experiment? Except me? Amazing. And to me, it's fucking amazing. Alright, so as I pointed out, I mean, all constant forces are time dependent. So if you're sailing your boat and you're in a wind, okay, how long you're in the wind, okay, will decide how much energy you collect from the wind. That's just the truth. How long your sail is catching wind is going to decide how much of that wind you convert into motion. So, and if you're crossing a stream, how fast you get across the stream will decide how much you're deflected and how much time you're going to be in the stream because of the deflection. So yes, the faster you go, the less force you'll collect from the stream. The slower you go, the more force you collect from the stream, and the higher your velocity in the direction you don't want to go. Just a fact. Alright, traveling across a gravitational well, okay, point A to point B. All that's going to matter is your velocity. The faster you go, the less deflected you'll be by the gravity. Just a fact. You're sitting in the sun, okay, the sun's out, it's shooting rays at you. They might as well be particles of paint. Alright, and it's just going to be about how long are you exposed to the sun and not in your little house. And that's going to decide how suntanned you get. Doesn't matter distance, doesn't matter where you go, circles, you spin around, doesn't matter what you do, it's just about time. How much time are you in the force? And that's all that's ever going to decide. And gravity, as proven by this experiment particularly, is just confirmable in the sense of that's what's happening when you drop something. I mean, it's just so obvious that you drop it 1 unit of distance, it's in 1 unit of time. Alright, and exactly the same experiment will take place right up here. Okay, this will be 1 unit of time. for this, you know. And if it's 10 meters, you know, I'm just saying, then you know it's 4.9 meters of distance, and it's 4.9 meters of distance. And you know you're going 9.8 because you're, that's what you acquire in 1 second. So 1 second, you get 9.8 of velocity. And then you're going 9.8, so you're going to keep doing these two distances you're getting for free because you're already going 9.8. So these two are for free. And this is the only new one you get, and it's exactly the same as this one. You get 4.9 of extra, okay, and you're going 9.8 more. So you're going 19.6 now. And then it'll happen again. So that's the 1, the 3, and then as Galileo pointed out, the next one's going to be 5. Because now you're going 19.6. So now you're going to get 4 of these 4.9s for free. You're going to get 4 units of 4.9 for free. No gravity needed. And you're just going to add one more. That's the 5. So 1, 3, 5, 7, 9, 11. Just keeps going on and on like that. And all you're adding each time is just 4.9 meters per a unit of time. That's the only extra distance you get from gravity. And the other thing you get is another 9.8 added to your velocity. And that's all you get. So after 5, you got 27. And it just keeps going on and on where you just 28. Yeah, 28. So it just keeps increasing, you know, at those rates. You go 9.8, then as next second you're going 19, and the next second you're going, well, if we say 10, 20, 30, 40, 50, 5 seconds, you're going 50 miles, 50 meters per second. It all adds up. It all makes sense. It's 2 units of time, 2 units of velocity, and that's it. There's no squared thing here. There's nothing like that happened. There's no way you could collect 4 units of energy from the gravity. You're only in it 2 units of time. You're in it 2 units of time. You can only get twice as suntanned. You go twice as fast, whatever the number would be, but you're going to get bent 1/2 as much. I mean, every single case, this is how constant forces work. There's no other way to look at it. There's no other rational way to explain it. You don't get force. You don't get 4 units of force. You're only in the paint spray 2 units of time. You only get 2 units of spray on you. I mean, how many ways can I make this argument? And I just don't know how are you defeating the argument? What do you think gravity is? A bent geodesic has a slope to it. And it's not a quadratic slope. It's not. Bent sheets don't make quadratic slopes. Anyway. So, yeah. So now we have 3 viewers. Okay, so yeah, I guess I will surrender. So I guess I'll give you a couple-minute warning if you have anything at all to say, the 3 of you. But yeah, it's just no point. I've gone over this stuff so many times, and it just, until I get a rational answer to these questions. I mean, how else can you interpret this function? Like I said, if I turn the gravity off right here after the first unit of time, I still get these 2 units of velocity. And I'll just keep getting them forever. I'll just keep going 9.8. Every second, I'll go 9.8 meters. Every second. I don't need any more force to affect me. I mean, it's... yeah. Well, whatever. It's just so weird. I never thought this would be the hard part, like I said. Doing the physics was the hard part. Coming up with all this shit was the hard part. And I just never figured that explaining it would be the impossible part. That somehow people would be obnoxious to these simple, truthful arguments. And again, all of the stuff I've discovered goes so far beyond this. This is the simplest thing. You know, the whole figuring out how charge works, explaining completely the double slit experiment. I mean, it's like you can't even argue any of the other subjects if they can't get this. How the fuck are they going to get some other, more complicated subject? It's just so depressing. But it's just a terrible planet. I mean, there's just so many people are scummy. Just so depressing to live on a planet full of liars and cheaters and connivers. Ugh. Alright, so yeah, I'll call it a video. So yeah, I'm going to attempt to construct some kind of durable experiment, okay? Some sort of lever launcher that I can use over and over and do all kinds of, some kind of permanent machine. Unlike these other people who do some contraption and then they tear it apart and we never see it again. It's, because there's so many ways you can use the device to test different things. And so I will do that, extensive testing. But don't count on it soon, because I really I just don't have any workspace here. And it's damn cold outside. I don't want to do it outside. So anyway, we'll see though. But apparently it has to be this way. I can't find anybody who can do these experiments, honestly. I mean, that stupid asshole has his air track, and what does he does nothing with it. Because he has to carefully do the experiment just this way, because if he does any other experiment, it's going to reveal the truth, and he can't let the truth out. And it's just so putrid that they haven't tested anything. I mean, we all know that rubber bands aren't perfect, right? So, I mean, this would be a good test to just shove your cart in, at a velocity. It hits the rubber band. What does it come back with? If it comes back with the same energy, something must be wrong, right? Because, rubber bands should take away a little. Tennis balls lose 75%. Super balls still lose 10. So, Anyway. Enough, I guess. And then you have to explain that. I'm just saying, all of a sudden, rubber bands are perfect. They don't lose any energy. You'd have to argue that, maybe they're creating some because the cart isn't hitting them evenly. Again, well, I've been through the air track flaws in the air track. I mean, you could just know it's a dangerous setup just because, you do have a huge amount of introduced energy. You're just arguing that somehow all the introduced energy is perfectly balanced and isn't going to do anything suspicious. And that's the wrong assumption. The assumption should be, all the cart has to do is tilt a little bit and it's going to create an exhaust and a velocity, and that's dangerous. And the fact they don't even concede that. I've never seen anyone ever critique an air track and point out how, it is a little bit dangerous because you have a ton of energy going in, and if it isn't just right, that energy is going to screw with your experiment. I mean, it's as simple as arguing about the little metal wheels on the plastic carts. I mean, no physicist could admit that's a pretty stupid way to make the carts. I mean, it maximizes the amount of energy that's stored in angular rotation. It maximizes it. You don't want to maximize that. You want to minimize that. You want the energy to be in the linear motion. You want to see the energy as linear motion. You don't want to not see it as angular rotation in axles and wheels. You don't want the energy hiding in axles and wheels. You want it visible in linear motion. See, even that. I mean, not to concede that that's a good argument. That, these aren't, that it does look a little manipulative that they've chosen to use mechanisms in their experiments that have obvious imperfections. Like, why did they do it that way? Why wouldn't you have big light wheels that store almost no rotational momentum. Okay, anyway, there's no point, right? I'm talking to the wind, talking to gravity, talking to dumb forces, and that's just tragic. Not much I can do about it, though. So I'll just do what I'm only can do my job. I'm doing my job, which is being a reasonable person. Can't do much that these assholes are assholes. Look, somebody has a silly name. Ashley Kennedy is a scammer. Yeah, I'm sure this is another person likely to make great contributions. Let's see. Newtonian mechanics predicts that rubber bands don't create more energy. I didn't say they create more energy. I said the air track does, you retard. Oh, God, you people are so fucking full of shit. You claim they do because you're whatever that is to explain why the experiments you have seen are fake. So again, I have no obligation to do anything other than point out the obvious. Okay, now you think it's okay if the computer software doesn't create the same tracking for the two experiments. That's okay with you, right? The tracking doesn't have to be the same. There shouldn't be any consistency. Why would you expect consistency? You're measuring two exactly the same things and the computer's not doing exactly the same thing, and you think that's just fine. You know what an asshole you are? I'm glad we have a permanent record of you being an asshole. Answer that. Just answer that question. What question? There's no question. Well, where's the question? No, you might be having another stroke. Whatever. You just go fuck yourself. Get what you deserve, you scummy pile of shit. Oh, God damn it. Just amazing garbage on this planet. Ugh. If an honest man ever becomes president, it might be just so fun to watch what could happen. Because there's just so many humans that have no right to be walking free. 2 million people in prison? Not nearly enough. God damn it. All these lying scumbags. Oof. It's just so... But, it proves my other philosophical point, that there's no point in existing because you have to exist in a cesspool of lying scum. I mean, what decent person would have a child in a world full of lying scumbags? Ugh, disgusting. Fucking people. You just can't be blighted soon enough. You just can't get it any worse than you deserve, you pieces of garbage.